Hello there, and welcome back. Today we'll be continuing our conversation on volcanoes and focus on predicting eruptions, types of volcanoes, and hazards. Volcanoes are separated into three main categories. The first is active, which is when the volcano is showing signs of erupting or will be erupting soon. The second type is dormant, which show no current signs of activity but has recently erupted. The final type of volcano is extinct, which is when the volcano has not had any activity for a prolonged period of time and most likely will not erupt again. As you can see, the two categories that we are most interested in are active and dormant volcanoes, and these are heavily monitored. There are certain signs that indicate a volcano might erupt, such as earthquakes, surface bulging, and emissions of gases. The movement of magma can shake the ground, which can also result in seismic activity. Typically, the number and size of earthquakes increases before an eruption, and scientists use increased seismic activity, including length and strength, to help predict a potential eruption. Slope deformation also indicates that magma and gas is rising and can deform the ground around it. This deformation of the slope is detected by a tilt meter, which simply measures the angle of the volcano's slope. In the case of Mount St. Helens, there was a bulge on the side of the mountain that continued to grow in size on the north side before it erupted. Another hazard associated to the slope deformation is landslides and falling rocks. Gas emissions is also monitored to help predict an eruption because gases may escape prior to magma reaching the surface, and scientists can measure gases at vents located on site. Depending on the amount and ratios of the gases are used to help predict an explosion. With the use of satellite technology, gas emissions from volcanoes and slope deformations can be measured more easily and over a broader scale. Regardless of these signs, volcanologists are still uncertain about when an eruption will occur, and scientists continue to improve the technology and the accuracy of their predictions to hopefully evacuate individuals in a safe and timely manner. Volcanoes vary in shape and sizes, and the shape is related to the type of composition of magma. The types of volcanoes we will discuss are composite volcanoes, shield volcanoes, and cinder cones. A composite volcano, or also referred to as a stratovolcano, is made up of alternating layers of lava and ash. They are conical in shape and is where it gets its name from. They are mainly located at convergent plate boundaries where subduction occurs. These volcanoes have a distinct crater, symmetrical cone, and a steep profile. Composite volcanoes are made of felsic to intermediate rock, and the lava typically hardens before spreading too far as a result of its viscous lava. Two volcanoes you might be familiar with that are composite volcanoes are Mount St. Helens in the United States and Krakatoa. Some composite volcanoes have a collapsed summit, and this forms a caldera, which is a volcanic crater that forms as a result of the magma chamber emptying and causing the summit to collapse. Shield volcanoes have a gentle slope and small vents, or a group of vents at the top, and are associated with mantle plumes. These volcanoes have non-viscous basaltic magma, meaning it is mafic lava. They primarily experience effusive eruptions and do not have layers of lava and ash. The name of these volcanoes gets its name from a warrior's shield because of their shapes, and the most well-known shield volcanoes are those that make up the Hawaiian Islands. They are also the largest types of volcanoes on Earth. Cinder cones are the most common type of volcanoes and are conical in shape and have a steep slope. These volcanoes get their shape because of mafic lava is violently ejected from a central vent into the air, and the cinder forms as a result of the lava cooling and solidifying. These eruptions are short-lived and are typically monogenetic, meaning they are the result of a single eruption and may last weeks to months. However, some cinder cones can last for a few years. Another type of volcanoes are supervolcanoes, which are extremely rare and dangerous. A supervolcano is a large volcano that erupted with the highest volcanic explosivity index of an 8, which is the largest recorded value on this index. This is a relatively new idea in volcanology, with the cause of these eruptions still debated, but scientists think that this is a result of a very large magma chamber. The magma rises to the crust but is unable to escape and continues to build pressure until the crust can no longer handle the pressure, and a catastrophic explosion occurs and can erupt over 1,000 cubic kilometers or 240 cubic miles of material. After erupting, this creates a massive caldera. The largest supervolcano in North America is located beneath Yellowstone National Park in Wyoming and sits above a hotspot that has erupted on 3 different occasions, 2.1 million, 1.3 million, and 640,000 years ago. An eruption from a supervolcano can impact Earth's climate severely because the ash can block so much sunlight that it affects photosynthesis and can drop the global temperature. In some cases in Earth's history, volcanic eruptions have been the cause of mass extinctions. Volcanoes are commonly located on convergent and divergent plate boundaries. The first stage in the creation of volcanoes is the result of mantle rock melting from increased temperature, lower pressures, or because water is added. Adding water changes the melting temperature of rocks because it acts as an impurity in softened rocks and enhances mantle convection. 75% of the Earth's volcanoes are located around the Pacific Ocean basin. These are a result of the abundance of convergent boundaries located here. This is part of the Ring of Fire. Keep in mind, around 80% of all earthquakes occur here. At subduction zones, magma can be forced to rise up as a result of plate subduction. Volcanic eruptions, as you can already assume, can have numerous hazards associated to them, and they can be either a direct or indirect hazard. Direct hazards are associated to forces that result in an injuring or killing of people and the destruction of land and property. Whereas indirect hazards caused by the volcanic eruption can lead to famine, habitat changes, and distress. Some main volcanic hazards are tephra emissions and gaseous emissions. Volcanic gases are dangerous with carbon dioxide, sulfur dioxide, and hydrogen fluoride posing some of the biggest health risks to humans, wildlife, and vegetation. These gases can cause acid rain, deplete the ozone layer, and can be flammable. Some gases, such as carbon dioxide, are heavier than air and can cause unconsciousness, along with other risks. In addition, a volcanic eruption can cause a landslide or a lahar, which is a mud flow that is a result of a volcano. Not to mention the damage that can be caused by a result of lava flow. In today's lesson, we covered predicting eruptions, types of volcanoes, and hazards. Thank you, and have a wonderful day.
1, 2, 3. Cheese.